Hi everyone, this is Mr. B, the math analyst. And today in our video, we're going to learn how to find missing sides and missing angles in non-right triangles. So if you're interested in this, please stay here and let's see how this works. Mentioned it in the introduction. Today we're going to see how to find missing sides and missing angles in non-right triangles. We already did that with right triangles, where we apply either Pythagoras theorem or trigonometric ratios. Okay, if you remember, in that first video, I showed you this picture that you can see now, where we need to understand that there are two types of triangles, the right triangles and the non-right triangles. For the first ones, for the right triangles, we can use the trigonometric ratios and the Pythagoras theorem. Okay, remember, trigonometric ratios, SOHCAHTOA, sine, cosine, or tangent. Okay, but for non-right triangles, they don't apply. Okay, we need to use other tools, and the tools that we have available are the sum of the angles in a triangle. Remember that when we add all the angles in a triangle, that equals 180 degrees. But now we're going to start seeing two other tools, the law of sine and the law of cosines. Okay, so today this video is about using the law of sines for finding the missing side or the missing angle in a non-right triangle. Before checking how the law of sine works, we need to understand how we label triangles. Okay, so that is why I have this image that you can see here. Okay, notice that this triangle is not labeled. Okay, so first we need to understand how we label a triangle. Okay, and let's start with the vertices. Normally, when we label triangles or any shape, we use capital letters to label the vertices. Okay, so for example, in this case, I'm going to use the letter A. Actually, it doesn't matter the letter. Okay, we can start with any other letter. I'm going to start with letter A, B, and C. Okay, so this is how I label the vertices. Now I'm going to label the sides. And basically the way we work is that we follow the same logic that we use with the vertices. So for example, the vertex A is here, and what I'm going to do is that I'm going to label the opposite side to A, okay, as lower A. Okay, if we follow that same logic and we do it with B, the opposite side to B is this one. So we'll label it as B. And now I imagine that you already got this. So the opposite side to C is going to be lower C. Okay, this is how we label the different sides and vertices of a triangle. Okay, now why we need to do this? Because the law of sines apply or works with this labeling. Okay, so now that we understood how we label the different vertices and sides of a triangle, now we need to understand how the law of sines work. And I'm going to reduce this image. Okay, and basically the idea is that it works with proportions. Okay, the law of sines works with proportion, and it states the following. It states that the proportion between the side A, let me move this triangle from this place that is here. Okay, better. Okay, so the side A to the sine of the angle A, so the proportion of side A to the sine of the angle A equals to the proportion of side B to the sine of B, and the proportion of the side C to the sine of C. So if we have to read it, what we're going to say is that the proportion A to sine of A equals the proportion of side B to sine of B, and equals the proportion of side C to sine of the angle C. Okay, this is what, let you notice better now. Okay, Now you can see better. Okay, so this is what we call the law of sines. Remember, this is applicable to non-right triangles. And actually, let me tell you something. It applies also to right triangles. Okay? Now, it could be written like this, or also could be written in the opposite way, like this. Okay? It doesn't matter which one you want to use. If you feel more comfortable with the first one than with the second one, then go for the first one. Okay? So let's see the first example so we can get used to this. Okay? Okay. So here you can see the first example. Okay, let me move it here. So notice that we have this triangle ABC. They are giving me the angle A, which is 30 degrees, the angle B, which is 70 degrees. They are also giving me the side BC, which is 7, and they are asking the side AC or lower B. Okay, so notice that it's a non-right triangle. Therefore, I cannot use trigonometric ratios. I cannot use SOHCAHTOA. I cannot use sine, cosine, or tangent, neither the Pythagoras theorem. So the only way I have currently is law of sines. Okay, so how we're gonna do this? Okay, since what I'm looking for is a side, I'm gonna start by writing the side I'm looking for. Okay, so because I want to find the value of side B. Okay, you can call it B or side AC as you feel more comfortable. Okay, so the side B, which is what is requested, is proportional, no, sine of B, capital B, which is 70 degrees. Notice that is the opposite angle to this side, okay? And now, what I'm gonna do is I'm gonna use two other pairs, an angle and a side that are given, okay? So in this case, the side A, lower A, and the angle A are those that are given. So I'm going to use them. Okay. And I need to keep the same order. If I started with a side, I need to start the second proportion also with a side. Okay. So I'm going to start with 7 like this. Okay. And below, I'm going to write sine of the angle A, which is 30 degrees. Notice that law of sines works just when we have three given values. So we have one side and two angles, and the other side is what is requested. Okay, so that is important. Okay, I already have my proportion set. So what I'm gonna do, I'm gonna solve this for B. So basically what we need to understand is that this sine of 70 that is here is gonna pass to the other side doing the opposite. At this point, it is dividing, so it's gonna pass multiplying. Okay? Okay. So 7 sine of 70 divided by sine of 30. Okay, so now what I'm going to do is I'm going to input this in my calculator. Let me clear this. Okay, and I need to input, remember that we need to tell the calculator that 7 sine of 70 is what we have in the numerator, and now divided by the sine of 30. Okay, and that is 13.2. Okay, so in other words, the measure of the side AC is 13.2. And in this case, the units are not given, so we don't need to write units. Okay, so that is the first example. In this case, remember, we found the missing side. Okay, now we're going to see the second example, which is finding the missing angle. Okay, so here we have it. In this case, it says that the triangle DEF, where DF is 7 and DE is 6. Okay, let me fix my drawing because there was a letter missing. Okay, and it says find the angle F. Okay, so they are asking me to find. I'm gonna shade this with red. So this is the angle they are looking for. Okay, and notice that I have the opposite side to this angle, and I have another pair of opposites, one angle and its opposite side. Okay, so that is a clear indicator that I have to use law of sines. Okay, now that I know that, I'm going to start writing what I'm looking for. I'm looking for an angle. So since I'm looking for the angle, I'm going to start writing sine of the angle I'm looking for. I'm looking for angle F. Okay, sine of F is to its opposite side. What is the opposite side? DE, which is 6. Okay, so basically remember, the sine F is to its opposite side as the sine E. The sine of 124 is to its opposite side. Remember that the opposite side of the angle E is the side, we can call it lower E or DF. Okay, so in other words, 7. So remember, that's the key. Angle, opposite side. Angle, opposite side. Okay, or in the other way, side, opposite angle, side, opposite angle. Always in the same order. Okay, now that we know this, we need to solve this for F. Okay, how? Well, first, this 6 that is here is going to pass to the other side. Okay, so I'm going to, basically, this is what I'm going to do. Side E is going to pass to the other side. It is dividing, so it's going to pass multiplying. Okay, that is the first step. I'm going to do that step by step. Okay, so sine of F equals 6 sine of 124 divided by 7. Okay, but remember that I need to isolate the letter F. So I need to pass the sign to the other side. And every time you pass a sign to the other side, it passes as inverse of the sign or arctangent. Arcsine. Okay, so basically, this is what I'm going to input in my calculator. Okay, so if you don't know how to find the inverse of the sign, notice that the calculator here, we have inverse of the sign, but it's in light blue. So that means that I need to press second first. If you are using a scientific calculator, it should be in yellow. Okay, label it in yellow. That means that you need to press shift first. Okay, so second sign. Notice that my calculator is showing me inverse of the sign. So I need to input first the numerator. Okay, so 6 sine of 124 divided, let me, so I notice that I close a parenthesis because I open the first parenthesis first. Okay, and now divided by 7, and I need to close all the parentheses. Okay, a key when you're working with calculators is that the same number of parentheses that you have opened is the same number of parentheses that you should close. Okay, so now enter, and the angle F is 45.3 rounded to 3 significant figures. So angle F equals 45.3 degrees. Okay, and this is how we use law of sines to find either missing side or missing angle. So I hope that this lesson was clear and was helpful for you. Before leaving, remember to click on the subscribe button so we can continue making these videos, and also give a like and share it with anyone that you consider needed. Okay, so that is everything for today. See you in the next video. Hasta luego.